So in this lesson, we're going to learn all about solubility. What is solubility? Some measurements for solubility, some factors that can affect solubility, and then we'll end things off with looking at solubility curves. So you may have heard this term before. If it sounds familiar to you, great. If not, we'll go over everything that you need. So solubility, in terms of a definition, it's the amount of solute that dissolves in a given amount of solvent at a specific temperature. So here we're looking more at amounts. How much of something can dissolve in an amount of solvent, and temperature plays a big role, which we'll talk about in a little bit, but at a specific temperature. We have three easy ways to classify solubility, and we call them degrees of saturation. One is called a saturated solution. This solution cannot hold any more solute in a given volume of solvent at that temperature. It has the maximum amount of solute. For whatever that volume is. Okay? You try and dissolve and dissolve and dissolve, and once you reach that point where the solution can hold the most solute, then we call it saturated. Another way to describe solubility is to call something an unsaturated solution. This one can hold more solute in that particular amount of solvent at that temperature. So what that means is you can dissolve more of whatever is there. So if you think about salt and water, I would add some salt to the water, stir, mix, and it would dissolve. If I add some more salt and it continues to dissolve and mix, that solution is unsaturated. It still allows me to add more salt, and that salt still gets dissolved. Then there's one other way to describe solubility, and this is more of a special case. This is called a supersaturated solution. In theory, this solution is holding more than the maximum quantity of solute than it should at that temperature. How do you get a supersaturated solution? Well, you play a little bit of a trick. So temperature plays a big role here. If you want to dissolve more, one way you can do that for certain solutes is to increase the temperature. So warm up your solution, let's say above room temperature. Dissolve as much as you can or saturate it at that warmer temperature, and then allow the solution to slowly cool back down to room temperature. You don't want to just throw it in a fridge or a cool environment. That won't work. Just leave it on the counter, and slowly over time the heat will dissipate and it will get to room temperature. Most solutions will leave that solute dissolve. So at room temperature, you wouldn't have been able to dissolve that much, but if you gradually cool it back down to there, it would work. If you've ever played with any crystal making kits or ever tried to make any crystals at home, it uses degrees of saturation and supersaturation to help you do that. If you're still a little bit unsure, maybe this diagram might help. I like this one. So you've got three test tubes with three different solutions in there. One's unsaturated, one's saturated, and one's supersaturated. So in the unsaturated solution, you add more of your solute and it dissolves. So big pieces, once it goes in the solution, you see them getting smaller, but in here it would dissolve. If you tried the same thing with a saturated solution, put your solute in, no more dissolve. So you see the crystals are in there, they haven't changed size, and they just settle at the bottom of the test tube. You can't dissolve anymore. That solute's just going to sit there. A supersaturated solution, what happens is it looks to be like it's all uniform and dissolved. But the second that you put any kind of your solute in there, it causes crystals to grow. Any of that extra solute comes out of solution. We're not going to worry too much about supersaturated solutions right now, but the two that are the most important for you to know are unsaturated and saturated. So what are some factors that affect solubility? The biggest one here is temperature. Temperature is a huge factor when it comes to dissolving a solute in a solvent, but you have to be careful for the state that you're looking at. So let's look at a few different scenarios. When you have a solid, the trend is if you increase the temperature, the solubility also increases or it's greater. Why does this happen? The solvent particles have more kinetic energy because the temperature's increased. You increase temperature, you have more kinetic energy. And then that means if they have more kinetic energy or moving around more, they're going to come in contact with those solute particles more often. So the fact that the solvent and the solute are moving around more due to that increased kinetic energy, you get more dissolving happening. What happens when you try and dissolve liquids? For liquids, if you try and dissolve one liquid into another, generally they're not affected by temperature. Why does this happen? We have to try and think about a couple of things. One, they're already in the same state, liquid, so that helps. They should have similar amounts of kinetic energy if you're changing the temperature. The other thing to consider is the bonds between the particles in liquids aren't as strong, so you don't need that extra energy to allow the dissolving to happen. They're already both in the same state. For gases, though, it's something different. And if you don't believe this one with gases, you can try your own little experiment at home. With gases, if you try and dissolve them in a solution, a liquid solution, it's the opposite for solids. As the temperature increases, solubility decreases. So temperature goes up, the solubility of gases goes down. It means they don't dissolve as well in higher temperatures. Why? Well, if you remember, gases, in terms of their particles, are moving around really quickly. They have lots of kinetic energy. So when they're heated, even if they are actually dissolved in a liquid, they get more kinetic energy. And they move and move and move, and all of a sudden they have nowhere else to move, and then they just escape out of the solution. And once they escape that solution, that means less of them dissolve, or the solubility goes down. Places where you might have seen this, or you can try at home. Glass of water. Now, if anyone puts a glass of water out on their bedside table before they go to sleep, if you get thirsty, this is a good trick to try. Get a glass of water with room temperature or with above room temperature water, so warmer water is something that you could do. When the temperature changes, you might notice that overnight the water has little bubbles that cling to the side. The other way that you could look at this phenomenon is when you have one of those big 2-liter pop bottles. What about if you keep that bottle of pop in the fridge versus on the kitchen counter? So you might notice a difference if anyone puts their bottle of pop that's been opened in the fridge. Does it stay fizzier longer than if you were just to keep it on the kitchen counter? There are a couple other factors to consider when thinking about solubility. One of them is the charge of the ion. In general, what you might notice, as the charge increases, the solubility goes down. Why can this happen? Well, we know charges are positive and negative. If those positive and negatives are stronger, that means the force holding the ions are stronger together. So it's going to be harder to break, which means harder to dissolve. The other factor considering ions is their size. So what happens with ionic size, the size decreases and the solubility follows along with it. It also decreases. So small ions, they're bonded more closely together than ones that are larger. So those positive and negative forces are closer together and are generally stronger. We can draw a quick little diagram here. Imagine you've got a whole bunch of different ions packing together, some small ones, and let's say there's some bigger ones here. If we look at the spaces between the ones that are bigger and smaller, here there might be a smaller gap. And in here you've got a really big gap. So when that water molecule wants to come in, and remember from the last lesson we talked about water dissolving, it's got to come in and disrupt the bonds between the positive and negative ions. So is it going to be easier for water to get into that smaller gap or to get into that bigger gap? It's probably going to be a bit easier to get into the bigger gap. Now what we're going to do are look at measurements of solubility, and they're on things called solubility curve. They measure solubility versus temperature. So on this curve here, we'll look at both scales before we start. On the y-axis, it has grams of solute per 100 grams of water. So it's grams of your solute divided by 100 grams of water. Why do they do this? Remember, 1 gram is equal to 1 milliliter for water. So really what they're saying here is how much in grams can you dissolve in 100 milliliters of water? But they keep it in grams. On the x-axis, there's a measurement of temperature, and we usually see that in degrees Celsius. So that's our curve there. And then throughout the curves here, you'll see different substances. So there's different lines representing how well different substances dissolve in water. Some are higher, some are exponential, some decrease, some are kind of plateauing in here. So we want to try and make sense of what's happening. So interpreting these types of questions and looking at the curves are something that you'll definitely encounter. So let's try out a couple together and I'll show you how to read them, and then you'll get some practice with your homework on this topic that'll help you understand a little bit more. So first question, what is the solubility of potassium nitrate at 45 degrees Celsius? So if we want to read this curve, first we need to find out where potassium nitrate is. So this is the curve for potassium nitrate here, the one that's in yellow. Since it's asking for solubility at 45 degrees, let's find out where 45 degrees falls on this curve. So here's 45 degrees. We go up until we hit the curve. It's about there. And when we go and look, it hits right at 70. So at 45 degrees Celsius, the solubility is 70 grams per 100 grams of water. This means 70 grams of potassium nitrate can dissolve in 100 grams of water at that temperature. So down here we can write our answer. At 45 degrees Celsius, 70 grams of potassium nitrate dissolves for every 100 grams of water. Some questions might get you to do the opposite. They might give you a solubility and ask you at what temperature does that occur. So the second question says, at what temperature does potassium chlorate have a solubility of 20 grams per 100 grams of water? So let's do the same thing. Let's go up here and we're going to find potassium chlorate. Potassium chlorate is this curve here. So here we want to look on our curve. Where's 20 grams per until we hit the curve, which is right down here, and that tells us the temperature is 50 degrees Celsius. So for this one, this happens at 50 degrees C. Some question might ask you about the state of a substance or what happens to the solubility of a substance. So question 3 is saying what happens to the solubility of ammonia as the temperature increases, and what state do you think the ammonia is in? So if we go up here and we want to try and find ammonia, let's get rid of some of this extra busyness here so it helps us see the question a little bit better. So ammonia is this curve right here. This one right here. So one thing you should notice that's different from a lot of other things, the solubility is decreasing as the temperature increases. Any guesses to what state ammonia might be in? The only one that fits that trend is a gas. As the temperature increases, the solubility decreases. Now there are some other questions where you might have to do a little bit of computing or calculating with your practice problems. So try those out and see how you do. There are a few other questions that ask you about if it's a saturated, unsaturated, or supersaturated solution. So when you're looking at these curves, if you're actually reading a point that falls right on the line, anything that falls right on the line is considered a saturated solution. If you're looking at a point for a substance and it falls below the line at that temperature, it's considered unsaturated. So let's say at 50 degrees Celsius, I see the solubility of potassium nitrate is 70 grams per 100 grams of water. Since that point falls below the curve, it's unsaturated. I would need to add another 10 grams to get to the saturation point at that temperature. And lastly, if you have a point above the line, so what if I was looking at something above the line at 50 degrees Celsius, anything above 80 grams per 100 grams for potassium nitrate, or any other example, that would be supersaturated. So hopefully this helps a little bit more with understanding on solubility. We've also got a couple of activities for you to work on this week, but try out some practice problems, especially with the solubility curves, and that'll hopefully help understand a little bit more about the dissolving process and solubility.